Hi, I'm Miss Hall, and this is Lesson 1, Part A, Parent Functions and Transformations, Vertical and Horizontal Shifts and Reflections. We'll begin with identifying function families. Functions that belong to the same family share key characteristics. The parent function is the most basic function in a family. Functions in the same family are transformations of their parent function. Okay, so at this point there are 4 families of functions that you should recognize. We have constant, which is simply a horizontal line, and the parent function is f of x equals 1. We have a linear function, whose parent function is f of x equals x. We have the absolute value function, with the parent function f of x equals the absolute value of x, and quadratic functions whose parent function is f of x equals x squared. And you'll see below visuals of each of these 4 types of functions, and you're seeing a graph of their parent function. What we're going to do with these functions now is start to transform the parent functions by shifting the graphs up or down, left or right, or reflecting over the x-axis. What we're doing is we're transforming the functions. So we're going to talk about describing transformations. A transformation changes the size, shape, position, or orientation of a graph. A translation is a transformation that shifts a graph horizontally and or vertically, but does not change its size, shape, or orientation. In example 2, we're going to be graphing and describing translations. So we're going to have to graph g of x equals x minus 4 and its parent function, then describe the transformation. Okay, so the parent function here, and I'm going to call this p of x, is a linear, this comes from the linear function family, so the parent function is x. And now on this graph, I'll graph g of x and p of x. I'll add a y-axis and an x-axis, x, y. Now you can graph this knowing what you know about slope-intercept form, or you could put it in your graphing calculator and go to table and plot some points. I'll use slope-intercept form right now. So for g of x, the y-intercept is -4. I'm going to go 1, 2, 3, 4. And the slope is 1, which is 1 over 1. So rise 1, run 1. Up 1, over 1, up 1, over 1. Here is g of x. Now p of x, the parent function x, has a y-intercept of 0, so it intercepts the origin, and the same slope, up 1, over 1. And here's my graph of p of x. So I graphed both of them, and now I'm supposed to describe the transformation. Okay, so the parent function to g of x is a translation, let's write this down, a vertical translation, and I can count 1, 2, 3, 4 units down. Right, to go from the orange graph to the purple, we shift the orange graph down 4 units. So in example 2, we looked at a translation that shifted the graph down, and a translation again shifts the graph up, down, left, or right. And in example 3, we're going to focus on a reflection. A reflection is a transformation that flips a graph over a line called the line of reflection. A reflected point is the same distance from the line of reflection as the original point, but on the opposite side of the line. Example 3, graphing and describing reflections. Graph p of x equals -x squared and its parent function. Then describe the transformation. Okay, so Negative x squared is a quadratic function, so it's from the family of quadratics. They've already used p to describe the original, so for the parent function I can't use p, I'll use n. N of x equals x squared. And I'll graph p of x equals negative x squared on the same axes. Let me add my y-axis and my x-axis. Now this is when you might be more likely to put in your graphing calculator and then look at the table and plot those points. And again with the parent function, x squared, so 0, 0, 1, 1, negative 1, 1, 2, 1, 2, 3, 4. So what I'm doing is I'm taking that x value and I'm squaring it. Negative 2, square it, I get 1, 2, 3, 4. Here's the parent function that I have labeled n of x. Now let's graph p of x. So what I'm going to do is I'm going to square the x value and then negate it. 0 squared, negate is still 0. 1 squared is 1, make it negative, negative 1. Negative 1 squared is 1, make it negative. Positive 2 squared is 4, make it negative 4, 1, 2, 3, 4. And then I can see that this is symmetric, so it's going to be negative 2, negative 4. Now I have p of x. Okay, describe the transformation. So this is a reflection over the x-axis. The x-axis is the line of reflection.